Here we are given a ladder resting against a wall, and ladder length is 10 feet. Okay, and ladder bottom from the wall is 6 feet. Ladder is moving away from the wall 4 feet per second. Okay, and we have to find the angle that is changing here when it is moved from away from the wall. I have to find here d theta over dt, the angle that is changing here. We have to find this. Okay, and so I call this is x, this is my r, and this is my dx by dt. Okay, let me adjust this diagram. Okay, okay, okay. So first of all, I can write cos theta equal to x over r. Okay, if I take here the derivative on both sides, so I can write dx over I can write d over dt cos theta equal to d over dt x over r. Okay, so further I can write minus sine theta d theta over dt, and here I can write dr dx over dt. Okay, and then minus x dr by dt. Okay, over r square. Okay, so we know this basic identity, sine square theta plus cos square theta equal to 1. So I can find sine value. So sine theta should equal to 1 minus cos square theta and square root. Okay, so in my equation I can write here minus, and sine theta value is square root 1 minus cos square theta, then d theta by dt. Okay, equal to, and if I look in the equation. Let me see 1 second. So r dx by dt is okay. Then minus, I can see this one, dr by dt is actually 0 because the ladder length is constant. So derivative of constant is 0. So I can write here x then 0 over r square. Okay, 1 second. Okay, I can write minus 1 minus, and cos value is x, so I can write here x square over r square, then d theta over dt. Okay, equal to r dx by dt over r square. Okay, if I simplify this further, I can write this minus then r square minus x square over r square and d theta over dt equal to I can simplify here. On the right side, this r will cancel with this r. Okay, so this should be, can write 1 over r dx by dt. Okay, 1 second, let me adjust this one. Okay, okay, so further I can write minus r square minus x square over r d theta by dt equal to, okay, so further we can write here minus and then r square minus x square over r d theta by dt, and right side we can simplify further. Okay, dr 1 over r into dx by dt. Okay, so this r will cancel this r. Okay, so we can write further. So let me adjust. Okay. So r square minus x square d theta by dt equal to dx by dt. Okay, so now we substitute the values and we can adjust. So minus r value is 10 feet, so 10 square minus x value is 6 square, then d theta over dt equal to dx by dt. Okay, so further we can write okay, so now we can write this is actually minus 8 d theta by dt equal to dx over dt is given, that is 4. Okay, so d theta over dt equal to 4 divided by minus 8. Okay, so it should be minus 0.5. So this is our final answer, d theta over dt equal to minus 0.5.